Now's the thing I've been excited to talk about because I know it's actually what you're really passionate about. Not that you're not passionate about all this other stuff, obviously, but I mean, digital detritus has been something we've discussed a lot over the years and was a big part of a companion article to the Pacific Rim story when we published it and back in October. And your piece on digital detritus was excellent and lengthy enough for a blog that I was calling it a novella. Uh, but like I know you're like really hot on this topic, and the more I think about it, I'm constantly seeing it everywhere. And you're talking about every device having value to an attacker. And I was walking down the street yesterday, and I'm like spying these private security cameras in front of some of the shops, and I'm like, oh yeah, I mean, I is it infected with Mirai still, or has it not been infected with Mirai yet? Is really the question for that device. And like as a vendor, it's a difficult thing to talk about, right? Because we have firewalls out there. We would like them all to be on current supported versions. I'm working with our team on a daily basis on trying to communicate to people the importance of this. Why, the you talk about shared responsibility in the article, and we talk about shared responsibility most of the time in our community when we're talking about the cloud. Like, where does Azure's responsibility end and yours begin, or Amazon, or Google Compute, or whatever it is? When we're talking about these firewalls, we've always kind of had this casual shared responsibility, I'll call it. Nobody talks about the shared responsibility of the customer consuming fixes, although we do have an expectation of the vendor providing them, and that we understand there's an end of life at some point. But when I go to the shop and I buy something, I don't know what the end of that life of that thing is expected to be. I mean, we're just starting to create norms here. I think, Apple tells you how long they'll support an iPhone. I believe Samsung and Google are doing similar with their mobile devices now, but that's about the only place I ever see that. Is that like a starting point for this? When I buy a new Sophos XGS firewall, do I know that Sophos promises I'll have 3 years, or is this something that goes on the label? How do we start?
So you've fast forwarded to some point in the future, some indeterminate point in the future, where I think that we will begin to see a kind of a shift in the industry where vendors, particularly hardware vendors, but vendors, also software vendors who are putting some sort of a footprint on the internet, where fundamentally just think of it this way. If it's a device that has an IP address and it has a listener that is going to accept some kind of an inbound connection on the internet, it would probably fall into this potential category of digital detritus. And and I'm not even going to include the kind of data plane vulnerabilities that could potentially be exploited with certain kind of well-crafted payload where a device doesn't even have to have a listener. Those exist, but they're relatively rare compared to the listener scenario. So that's the part that I want to focus on. And usually these devices are providing some kind of utility. They're a firewall, they're a remote access device, they're a video surveillance device, something that somebody intends to use for some beneficial purpose. They need to be able to interface with it as a human, or maybe it's a machine-to-machine interface that qualifies for this as well. And some attacker figures out, number one, how to enumerate these things. And there are plenty of tools out there that facilitate the enumeration, basically scan all IPv4 space in a matter of seconds. And we're working on scanning all of IPv6 space now. And it's easy to create this map of what the attack surface looks like. What devices are there on the internet that are listening? And then you could begin to classify them. And then you could say that these are running some derivative of a Linux operating system. These have some kind of an embedded OS on them. I'm going to go after the Linux stuff, and there's tons and tons of Linux devices out there. So digital detritus refers to the combination of all of these devices that are getting deployed increasingly and cumulatively out on the internet, and there are billions of them at this point, that end up in some state of dereliction. And by that, I mean that they have been abandoned by the vendor because they're so old that the vendor is just not providing firmware updates for them anymore, but they still work in some way. And this is true for a webcam that maybe you bought 10 years ago that you're still using somewhere in your house. You haven't upgraded it because you haven't had to. The thing still works. But when was the last time it had any kind of a firmware update? Probably 5 or 6 years ago. And there's just this proliferation of devices that are out there that are operating in this kind of abandoned mode right now. Now, I think it eventually will take the form of vendors imposing some sort of a life cycle on the device, meaning that there's a clear statement up front of this is when the thing was created. This is the length of time for which we're going to provide firmware updates. After a certain period of time, we're not going to provide firmware updates anymore. Maybe we're only going to provide security fixes. And then after that period of time, we're just not going to provide any kind of an update at all. And the paradigm is probably most familiar to everyone because that's effectively how Microsoft treats the Windows operating systems. They work in the same exact way. Now, it's number one, it's impossible to expect that a vendor is going to provide updates forever. There is no such thing as forever. It's economically infeasible, and the cumulative cost of doing that would bankrupt every single vendor over a long period of time. So there is no such thing as forever. So what is a reasonable amount of time? Well, it depends. The typical kind of life cycle for a firewall, if you look at industry averages, is probably like 5 years or so. So is it a reasonable expectation that firewall vendors will say, when you buy this firewall, the day that it comes out, we're going to support it for a period of 5 years, and then there's going to be this decay of support where it won't be like feature updates and just be security fixes and then no updates after that? It's difficult for any one vendor to go out on a limb and claim that they're going to do that, because the moment they do, they put themselves at a competitive disadvantage to everyone else in the industry who isn't doing that. Because what they're doing is they're raising the cost of owning the device to the end user. Now, we have to think about how do we come up with the right economic burden model to be able to share that cost correctly. It can't be imposed entirely on the buyer, it can't be imposed entirely on the vendor. So there needs to be some sort of a distribution of cost when it comes to this. And when you begin to factor in the broader set of interests within the cybersecurity industry, and you think about cyber insurance, for example, the cyber insurance companies, they need to start thinking about this as a component of who they're underwriting and the premium structure that they have associated with that. If one of their customers has a firewall, but that firewall is 10 years old and hasn't had a firmware update for 5 years, is it the same thing as the customer who also has a firewall, but it's up to date and it's well maintained and has well-designed policies? Completely different set of economics associated with it. So I think we're at the very, very early stages of beginning to think through what the economic impacts and considerations of that are. I think eventually it is going to lead either to some form of legislation, some form of an incentive structure that's going to come from government entities, or it's going to come through some form of coalitions or pacts and levels of attestation, levels of certification that the vendor community themselves will begin to construct. Whichever form it takes, I can't wait for it, because I think this is going to be the way that we solve this digital detritus problem, which at this point is only getting worse every single day.
Yeah, it seems like insurance is an interesting place to start, right? Because I was actually going through our active adversary report that we published last week, this morning for another video interview I was doing, and I happen to still have my notes in front of me. And in our 190 cases that we processed in that report, which was from January 1 to June 30, 2024, 30% of those cases, the initial intrusion was through an exploited edge device.
Mm-hmm.
So that seems like economically a pretty easy argument to make with cyber insurance companies, considering the cost of these incidents.
Yeah.
I mean, and to your point, it kind of, this isn't just big companies that are being targeted with certain brands of firewall. It's all kinds of brands of edge devices, and particularly in this data set, 80% of the victims were below 1,000 seats. So it's happening to small and mid-sized companies up and down Main Street all over the country, right? I mean, it's just everywhere, and I think that's an interesting spot, because I can relate it to other things in my life as well. I go, well, my car, because it has an alarm and a bazillion safety features because it's 18 months old, I get all these discounts when I sign up for my insurance because it's safer to operate. And it's clear to the insurance company that it's highly unlikely I'm going to have the same kind of accidents. It's got a backup camera with sensors. I'm not going to back over a child. Things that are, tragic and horribly expensive to the insurance company. And no different than well, I think the actuary tables are a real challenge in cybersecurity, right? Because I don't think we have really good data for most things. I think in this case we do, but like we know sprinklers in a warehouse are likely to reduce mass fires by X, and we know exactly what those costs are over the last 100 years. Whereas in cybersecurity, I think if you got 5 of us in a room, we'd have 5 different answers to what the biggest problem is, which makes it hard for the insurers, I suspect. But so I mean that I think anybody that works in software security understands what you're saying right away. The question is, um, how do we get past some of this? Because not all of it's on purpose, right? Like we have customers that were acquired by another company. They don't know they have our products. Like there's a lot of things out there. So like I know you mentioned hot fixing at the beginning of the conversation. Is that something that needs to be industry standard? Because I went to update some of my devices because I've been on and off work a little bit coming into the Christmas holidays here. And I can't even find where to get the firmware for some of my gear that's on my network that I know there must be new firmware, but I like finding the bin file somewhere is like a challenge in its own.
Yeah, so the firmware update mechanisms in many of the devices that you own and I own, they're adversarial on their own. So yeah, I understand that experience. This does come back to the shared responsibility model that you mentioned previously. And basically, number one, the vendor is responsible for providing the fix. But in the current model, the prevalent model, most vendors will not automatically push firmware fixes down to devices. Some of them will provide a setting that says automatically update when a new version becomes available, but that tends not to be the default. The default tends to be notify me when there is an update, and I will download the update and I will apply it, or I will apply it through the user interface. And it's true for security devices, it's true for consumer devices, that tends to be the current prevalent paradigm. What we've been doing for years with our firewalls is we have a hotfix mechanism, which is on by default, and it's possible for users to turn it off. But so long as they don't turn it off, when we determine that there is some critical update, we can use that hotfix mechanism to push it down. And it will automatically apply itself. And we construct the hotfix in such a way, as I mentioned before, that it will not interrupt operation. The reason why the industry doesn't support the model of when new firmware is available, we're just going to push it down and upgrade everything is because it tends to be disruptive to business, and it can be unpredictable. And no business wants an unpredictable kind of a disruption where it can happen to them at any time. Even doing it at 3 o'clock in the morning on a Saturday night, that doesn't matter. They don't want that sort of thing happening. So that's why we've never seen that within the industry. We accept that as normal, but it's just not good enough. Like we have to do something better than that. We can't just say it's available, maybe you'll find it, maybe you'll apply it, maybe you'll get it done before you actually end up getting exploited. That model is just not working too well. So I do think we need better compartmentalization of the code updates that we're doing. So, I mean, this begins to get into the architecture of the devices themselves. As a vendor of a device that lives on the internet and provides some sort of utility access, do you have an ability to update components of code without reflashing the entire firmware? You have to lay down an entirely new file system where it's going to take 5 minutes for the update, and then you need to reboot once or twice before it actually takes effect, to where you're going to provide 30 minutes of interruption to your customers as part of your update service. No, you can't do that sort of thing. So making the investments in this kind of modularity in the architecture to where you can patch components of it on the fly. And we see, like, you can look at the evolution of the Windows operating system itself. Like, for those of us who have been around a really, really long time, we remember the days where if you were updating a video driver, you had to reboot your operating system for that to work. And that's not the case anymore because Microsoft has made tremendous progress in the modularization of the way that they update components of the operating system. It's still not, you never need to reboot. Sometimes you need to reboot, except it's 1/10, 1/20th what it used to be. I think that the cybersecurity vendors need to follow the same sort of path where we endeavor to make it less disruptive to update components of the code and then automate that. It's a lot easier to drop a TCP connection than it is to drop the entire box for 20 minutes. Customers will tolerate having to relog into an SSH server or hit refresh on a web page. They probably won't tolerate you taking the network down for 20 minutes. So let's do that. Let's get to a model where it's interrupting individual TCP connections and protecting hundreds of thousands of customers. That's something that I think the market can bear.